Welcome back, guys. In this new video, we're going to work out calculations on the amount of energy that flows to and from systems. So in this first question, it says an unknown gas expands in a container, increasing the volume from 4.3 liters to 8.2 liters at a constant pressure of 931 millimeters of mercury. Now for part A, it says calculate the work done in kilojoules by the gas as it expands. Now, because of the way that the formula for work is set up, we'll have an answer in liters times atmospheres. Now, what we should realize is there's a conversion factor to go from liters times atmospheres to joules. This is the conversion factor you need to know. So we're going to say 1 liter times atmospheres equals 101.3 joules. So we're looking for work, and we say that the formula for work is work equals negative pressure in atmospheres times the change in volume, which is just final volume minus initial volume. Now the units for volume will be in liters. Now I give you 931 millimeters of mercury, so the first thing we need to do is convert that to atmospheres. So we have 931 millimeters of mercury, and hopefully you guys remember that for every 1 atmosphere we have 760 millimeters of mercury. So this and this cancel out. So just remember that conversion. We're going to say 1 atmosphere equals 760 millimeters of mercury, and also 1 atmosphere equals 760 torrs. These are all just units of pressure, and these are the conversion factors you need to remember. So when we do that, we get 1.225 atmospheres. So there goes my pressure in atmosphere, so I can plug that into my formula. So negative 1.225 atmospheres times the change in volume, which is final volume minus initial volume. So 8.2 liters, which is our final, minus 4.3 liters. Now what we do there is it's going to give me negative 4.7775 liters times atmospheres. Those are our units. Remember, I want the answer in kilojoules, so first we have to convert liters times atmospheres to joules. So we want to get rid of liters times atmospheres, so we put that on the bottom. And remember, for every 1 liters times atmospheres, we have 101.3 joules. We want to change joules to kilojoules. Remember, we want to get rid of joules, so it goes on the bottom, kilojoules go on the top. Kilo is a metric prefix, and we said that 1 is associated with the metric prefix. 1 kilo is 10 to the 3 joules. Multiply everything on the top, divide by everything on the bottom. Remember, 10 to the 3 is also equivalent to 1,000. You could also plug that in. When we do that, we get negative 0.483961 kilojoules. And here we'll just round it to 3 sig figs. Here I'm not asking you for the number of sig figs directly, so we can just keep it at 3 sig figs. So it'll be negative 0.484 kilojoules. That's the amount of work that the system is doing on the surroundings. And remember, we know that the system is doing work because we say that anytime we use the word expands, the volume is increasing, and what's causing that increase? Our system.